Good day, everyone. I am Mr. Vincent Alonzaga, a PhD mathematics student, and I am going to discuss to you about how Mann-Whitney U-test can be applied in the given problem and how to analyze and interpret the data using the SPSS. So we all know that the Mann-Whitney U-test is used to compare whether there is a difference in the dependent variable for two independent groups. It compares whether the distribution of the dependent variable is the same for the two groups and therefore from the same population. The test ranks all of the dependent values, that is, lowest value gets a score of 1 and then uses the sum of the ranks for each group in the calculation of the test statistic. Therefore, the Mann-Whitney U-test makes no such assumption. The Mann-Whitney U-test and SPSS. So we have here the following three examples of problem or the statement of the problem. So assume that the samples did not come from a randomly distributed population. So we have here problem number 1. Is there a significant difference in the students' mathematics performance between the pretest scores using video-assisted instruction and traditional instruction? Number 2, is there a significant difference in the students' mathematics performance between the post-test scores using video-assisted instruction and traditional instruction? Problem number 3, is there a significant difference in the mathematics performance of the students when classified according to sex? So these are the following needed data in solving or applying the Mann-Whitney U-test. We have the video assisted instruction scores, the pretest scores, and the post-test scores. And also for the traditional instruction, the pretest scores and the post-test scores. We have also here the mathematics grade and sex, that is male and female. So now we are going to discuss problem number 1. Is there a significant difference in the students' mathematics performance between the pretest scores using video-assisted instruction and traditional instruction? To determine the significant difference in the students' performance in mathematics between the pretest scores using the video-assisted instruction, the traditional instruction, the researcher used Mann-Whitney U-test set at 0.05 level of significance. So first thing to do when we are using the SPSS, so we need to encode our data in the SPSS statistics data editor, then label its variable. Step number 2, click Analyze, then the non-parametric tests, then the legacy dialogues, then proceed to 2 independent samples on the top menu as shown in the picture. Step number 3, you will be presented with the 2 independent samples test dialog box. Step number 4, transfer the dependent variable, the pretest scores into the test variable list, and the independent variable, which is the group pretest scores, into the grouping variable box by using or by dragging and dropping the variables into the boxes. Make sure that the Mann-Whitney U checkbox is ticked in the test type area and the grouping variable box is highlighted in yellow as seen above. If it is not highlighted in yellow, simply click your cursor in the grouping variable box to highlight it. Step number 5. Click on the Define Groups. The button will not be clickable if you have not highlighted the grouping variable box as instructed in step number 4. You will be presented with the following screen. Step number 6, enter 1 in the group 1 box and 2 in the group 2 box. Remember that video instruction labeled as 1 and traditional instruction labeled as 2. Step number 7, after clicking continue button, it will bring you back to the main dialog box. Then click OK button to generate the output for the Mann-Whitney U test. And lastly, the step number 7, the given result will be used for interpretation based on the statement of the problem. So this is how we are writing our result in our research paper. So we have table 1. We have Mann-Whitney U test results for significant differences in students' performance in mathematics between the pre-test scores using video-assisted instruction or the experimental group and the traditional instruction or the control group. So we need the data for N, the mean rank, the Mann-Whitney U value, the C value, the P value, and the remarks. So for the video assisted instruction, we have 34 with the mean rank of 11.94, while the traditional we have 34 with the mean rank of 11.85. The Mann-Whitney U value, we have 553.500. With Z value, we have negative 0.303, and our P value, which is 0.762. So take note that our P value here, or the result of our P value, is greater than 0.05. So it means not significant. So we are going to um, accept the null hypothesis. So for the interpretation and conclusion, the difference in the students' mathematics performance between the pre-test scores using video-assisted instruction for the experimental group and the traditional instruction for the control group. So the Mann-Whitney U test results in Table 1 show that there was no significant difference between the pre-test scores of students using video-assisted instruction for the experimental group and those of students using the traditional instruction or the control group, with the Mann-Whitney U value of 66 is equal to 553.500 with P value that is 0.762. This result shows that both groups were performed homogeneous since the topics in the study were not yet introduced and discussed. Therefore, the students had the same background lessons in mathematics. It also shows that the students in both groups had equal knowledge in the subject area. So let us now proceed to problem number 2. Is there a significant difference in the students' mathematics performance between the post-test scores using video-assisted instruction and traditional instruction? So to determine the significant difference in the students' performance in mathematics between the post-test scores using video-assisted instruction and traditional instruction, the researcher used Mann-Whitney U test set at 0.05 level of significance. So in this case, same process will be done in applying the Mann-Whitney U test. So the two independent sample test here will be now the post-test, and the grouping variable, we have the group for post-test scores for the video assisted instruction scores and for the traditional post-test scores. So this is the result of the given data. So we have the Mann-Whitney U value, we have 245.500. We have the Z value with negative 4.095 and the P value we have, which is 0.000. So in this result, we have table 2, Mann-Whitney U-test results for significant differences in the students' performance in mathematics between post-test scores using video-assisted instruction, the experimental group, and the traditional instruction or the control group. We have the p-value, which is the 0.000, and that implies significant because the p-value is less than to 0.05 level of significance. So it means that, so the Mann-Whitney U-test results in table 2 show that there was a significant difference in the students' performance in the mathematics between the post-test scores of the video-assisted instruction. We have the mean, which is 22.65, and the traditional instruction, which has a mean rank, which is 24.90, the U value, which is 245.500, and P value 0.000. A significant difference was noted in the performance of the students in both groups, with the experimental group having better improvement after using the video assisted instruction than with the control group. In addition, the 8-week duration of the experiment resulted in better mathematics performance of the experimental group. One of the reasons could be the proper selection of videos presented to the students which they clearly understood. And when they were watching, they interacted and engaged in class discussion. So in this problem, so we reject the null hypothesis. So let us now proceed for problem number 3. Is there a significant difference in the mathematics performance of the students when classified according to sex? To determine the significant difference, the mathematics performance of the students when classified according to sex, the researcher used Mann-Whitney U-test set at 0.05 level of significance. So for the 2 independent sample test, we have we have to click the mathematics grade or the math grade, and for the grouping variable we have the sex, which is 1 for a male and 2 for the female. So this is now the result of the given data. So we have the Mann-Whitney U value, which is we have 137.0000. The C value we have negative 0.263, and the P value, which is 0.793. So let us now give the result or the given interpretation. So the Mann-Whitney U-test results for significant differences in the mathematics performance of the students being classified according to sex. So we have the p-value, which is 0.793, which is that implies not significant because the value is greater than the level of significance, which is 0.05. So in this case, results in table 3 show that there was no significant difference in the mathematics performance of students when classified according to sex, with the U value 131.000 with P value 0.793. This implies that sex do not determine the extent of students' performance in mathematics. So thank you, and God bless everyone.